Assalamualaikum and hello everyone. This is our presentation for MSD2 MDB 4053Z. This is the outline of this presentation starting from introduction until project management. This is a big introduction to this project. Malaysia is the second largest palm oil after Indonesia. Based on the oil palm planted area in 2018, it covers up to 5 million hectares for every palm oil mill. There must be at least one boiler to generate electricity through steam turbines and processing purpose. The outcome from the palm oil mill can be categorized as either main product or byproduct. Empty fruit bunch usually left untreated. In Malaysia, one of the significant contributors to the economy is oil palm production. Biomass waste from palm oil mill like AFB, mesocarp fiber generally generates large quantity of waste. So the strategy for waste management in palm production needs to be underlined. Nowadays, the method that been practiced is that they will use AFB as a biomass fuel for the application of their boiler. However, shredder often subjected to wear and tear issue. There are three objectives of this project. The first one is to evaluate the current empty fruit bunch cutter machine in the market. The second one is to analyze the specification of cutter machine individual component. The last one is to design an AFB cutter system. The aim of this project solely focus on the byproduct of the palm oil processing in mainly the AFB cutter machine. This research will specifically cover the pressing and cutting process of the empty fruit bunch. The aim at creating an efficient machine that combines two conventional processes used in industry like pressing and cutting processes. To design the biomass plant, we decided to choose Soroja palm oil mill as a datum. The mill's rated throughput is 45 metric tons of empty fruit bunch per hour. For the time being, EFB produced from mill is just being sold to outsider for mulching. The picture shows how EFB is produced by receiving the fresh fruit bunch. As I said earlier, the design were taken from the Sroja palm oil mill as a reference. The design process flow diagram is used as a reference of designing step of this project. The physical and functional decomposition of the overall system is done to give better understanding in how the overall system works. In this section, alternatives of each component are introduced and brainstormed. From here, the conceptual generation is made. This part of this project will focus on individual concept generation idea. Each concept generated will be evaluated and justified. We use weighted decision metric and Bach selection chart to evaluate the concept.
Hi, I am Yusri Hafiz and I'm going to proceed with the concept generation. So, for physical decomposition, there will be four main equipment for the system, which are EFB crusher, EFB fiber press, conveyor, and EFB shredder. So this equipment will have different functions, such as for EFB crusher, it will crush the hard EFB before we proceed with the shredder. For EFB fiber press, we are going to press the fiber and reduce its moisture content. So for the conveyor, we are going to convey the product from one equipment to another. And lastly, for the EFB shredder, we are going to shred the EFB to become fiber. So in the next chapter, I will explain about the morphological approach that we use in our project. For each equipment, we have chosen four different models from the catalog. So from this different model, we are going to emphasize on several specs. For example, for this EFB presser machine, we are going to emphasize on its capacity and its power consumption. For EFB shredder, we are going to focus on its power consumption, which been consumed by the electrical motor that been used to running the equipment, and also on the fiber length that been produced by the shredder. Next, for the fiber presser, we are going to emphasize on its power consumption and moisture content. For the moisture content, it is very essential aspect for us to consider before we send the fiber into the drying system. And lastly, for the conveyor, we will focus on the process suitability, which is which conveyor is suitable for which products, and also its maintenance costs. For this project, each of us has come out with our own conceptual design, and the selected design is came from Mr. Afham. For the design selection, weight matrix has been used to make our decision. And these are the justification why we choose Mr. Afham's design.
Next, we will look into the governing equations which is related to our project design. And here we have the constant variables, which means it is pre-described and we cannot blindly. First, let's see the governing equation for the EFB screw press and fiber press. So we have first same concept like just now, but here we have a higher RPM at the driven shaft. One. For the engineering design detail, our aim for the biomass production, and here is our biomass plant layout design. This is the EFB presser and fiber presser assembly design, and it consists of several parts. Meanwhile, here we got the EFB shredder assembly design. The next one is the scraper chain conveyor. The one on the left is the chain only conveyor. And we have the last design, which is the screw conveyor. For the capital expenditure, based on our calculation, we require 6 AFB presser, 3 AFB shredder, and 4 units of conveyor system, and the total cost is shown here. And for the OPEX, in order to generate 12 megawatt of power generation, we need to purchase extra AFB, which is shown here, and we include some other criteria, which is a machine. And with this criteria, we develop a cash flow diagram, which is shown here, and based on our calculation using the Excel formula of IRR. So for the project management part, this is our Gantt chart, which be covering the mechanical system design 1 and 2. And according to this, at week 10, we'll expected to finish our parts. For the project analysis, we develop an activity on node network, which is shown here. The activity will be covering the part of our report, which is introduction. And to calculate the critical path of the project, we will be utilizing the slack time formula, which is slack time equal to latest start minus earlier start. And if the value be equals to 0, based on our calculation, those activity which is A, C, E, G, and H shows the result of 0, which gives them the qualification to be a part of the critical. So as you can see here, since A, C, E, G, H is a critical path, we can highlight this path as a critical conclusion, the system has been successfully designed. The system can support every segment of sustainability because it reduces energy usage, and for best utilization,